When we were evaluating expressions, we were given values for our variables that we inserted into the problem. And then we simplified it the best way we could. We used the substitution principle to pull those values in and insert them into the problem. But as soon as we add an equal sign and to an expression, we've changed it a little bit. We now call it an equation. So the equation, I'm going to change the expression here because we are now going to be working with equations. And we don't evaluate an equation, we usually solve it. We're solving the equation. At this juncture, we don't know what the value of x is. We have to find that out. So we're really not substituting anything either. What we're doing is using some of our properties. The inverse property, the identity property, the property of opposites. Inverse property told us that if the opposite of multiplication is division, the opposite of subtraction is addition. So sometimes it's referred to as the property of opposites, and sometimes it's called the inverse property. And we're going to look at our problem now with two sides of the equation happening here at the equal sign. I could just draw a line and have two sides to this, my left-hand side and the right side of this problem. And what I want to do is get all of my number values on one side or the other and leave my x, the unknown, by itself. In this particular case, the way that I can get x to be by itself is if 11 jumps over this wall and joins up with the other like term. Because numbers are like terms. So I want my 11 to be over here with my -4. In order to get 11 to jump the wall, I am going to have to do the inverse operation. This is an addition problem. I'm going to need to subtract in order to get this to be 0, to make it go away. But whatever I do to the left-hand side of the equation, I must also do the exact same thing over here to the right. Plus 11 minus 11 makes a 0 there. It cancels that out, and the x is now finally by itself equals the combination of these two terms. I have a -4 and a -11. Are the signs the same? Yes. I'm going to add these two numbers and copy the sign of the larger numeral. 11 is bigger than 4, so I'm going to copy 11's sign. X is equal to a -15. I now have found what my x means. And if I were to put this value back into the original equation, -15, +11, I should get a -4. -15, +11. The signs are different. Signs are not the same, so we're going to subtract, and we're going to get 4. And the 4 takes the sign of the 15 because the 15 is the larger numeral. So -4 equals -4.